Haya.
You are provided with 1 solid K, 2 aqueous ammonia, 3 aqueous sodium sulfate, 4 dilute nitric 5 acid, 5 wooden splint. Solid K is suspected to be lead 2 carbonate. A. From the reagents provided, select and describe 3 tests that could be carried out consecutively to confirm if solid K is lead 2 carbonate. Write the tests and expected observation in the spaces provided.
That are shown in the board. We have a solid K, aqueous ammonia, aqueous sodium sulfate, dilute nitric 5 acid, a wooden splint, and then a solid K, which is suspected to be lead 2 carbonate. Now, from the reagents provided, select and describe 3 tests that could be carried out consecutively. Now, this is a very important one, consecutively. Consecutively means the first one should be the first, the second should be the second. So the one which is supposed to be in test 1 should be in test 1, test 2 should be in test 2, and then test 3. So, we have been told we are having lead 2 carbonate. What do we do to lead 2 carbonate so that it can dissolve? We are supposed to add what? Dilute nitric 5 acid? How much dilute nitric 5 acid do we put? We put lead 2 carbonate to be in excess, but dilute nitric 5 acid to be less. Are we together? So that all the lead 2 carbonate does what? Dissolves. But we have a wooden splint. Then what's the function of the wooden splint? To test for any gases which are produced. So when we react lead 2 carbonate with dilute nitric 5 acid, carbon 4 oxide gas is produced. What does it do? It extinguishes a burning splint. Are we together? So how are we going to do that? We'll say what? Add excess lead 2 carbonate to what? To dilute nitric 5 acid, which should be present in a boiling tube or a test tube. Are we together? But we try as much as possible to quantify what we are using. Okay? So you can say add excess lead 2 carbonate to what? To dilute nitric 5 acid. To dilute nitric 5 acid. Okay? Okay? Then you say what? Test for any gas produced using what? Using a burning split. Have you seen that? Now, what are the expected observations? So the first thing is that the lead 2 carbonate dissolves. Are we together? The lead 2 carbonate does what? Dissolves. The second thing is that there are gases which are produced. Okay? Bubbles of the gases which are produced. What is the behavior of this gas? The gas extinguishes a burning split. Why? Because the carbonate will produce carbon 4 oxide. And carbon 4 oxide does not burn nor support burning. That's from the theoretical aspect. So here we start by saying solid dissolves. That is one observation. Okay? Okay? To form what? To form a colorless solution. Okay? To form a colorless solution, as we have written on the board. Are we together? Now that solution is a solution of what? Lead 2 nitrate. Definitely because we had excess of lead 2 carbonate. Some of it will remain at the bottom of the what? Of the body too. Are we together? Some of it will remain at the bottom of the body too. So we are talking about what is on the top. Are we together? You can also do what here? You can filter, but you don't have a filter paper. That's why we are not going the direction of filter. Are we together? Let us not introduce what was not there. What was not there. So you see here, gas produced, okay, extinguishes a burning splint. So we are done with the first part. That is the first test. Now for the second test, test 2. We are done with test 1. We are now in test 2. Now what do you think we should do for test 2? We are already done with nitric fiber acid and wooden split. Which one will come first between aqueous ammonia and aqueous sodium sulfate? Aqueous ammonia. Suppose we start with aqueous sodium sulfate. Okay? So we start with what? Aqueous ammonia. So what will you do? So there's something we forgot on top here. We are supposed to do what? To decant about 2 ml of the what? Of the solution into how many? Into 2 separate test tubes. So you don't forget that. So you say decant 2 ml. Okay? 2 ml. That is 2 cubic centimeters of what? Of the solution. The solution into how many test tubes? Into 2 test tubes. Into 2 test tubes. Okay? Then you now go to which test? Test 2. Okay? What do we do in test 2? We say to the what? To the first portion in the test tube. To the first portion. Are we together? Add aqueous ammonia dropwise until in excess. Are we together? So we see to the first portion, add aqueous ammonia dropwise until in excess. Now, what will happen if these 2 ions are present? Aqueous ammonia only does what? Forms a white precipitate which dissolves in excess of what? Zinc ions. Are we together? So here, because lead is present and it is aqueous ammonia that we are using, we'll say what? White precipitate formed. And the precipitate does not dissolve in excess. So you write that. So expected observation. White precipitate does not do what? Does not dissolve. So it means lead or any other compound which forms a white precipitate does not do, is present. Then lastly, that is test number 3. test 3. Okay, test 3. Then we have expected observation. Expected observation. So we say what? In test number 3. To the second portion, add sodium sulfate. How much of the sodium sulfate? We must quantify again. We say 3 drops, 4 drops, 5 drops. But for most of the experiments, you usually use how many drops? Only 3. Okay? So you say to the second portion, add sodium, add how many? Add
3 drops.
3 drops of sodium sulfate. Good. What do you expect? Sodium sulfate will react with lead 2 nitrate, or lead ions will react with sulfate ions to give us what? Lead sulfate, which is a white precipitate. So here, the expected observation, you write white precipitate formed. And that way, we will have done what? Confirmed the presence of lead 2 carbonate. I hope you have realized that the carbonate ion was actually tested by use of what? A burning splint. Because carbonate produces carbon 4 oxide. Carbon 4 oxide does what? Extinguishes a burning splint. Is that clear? Okay, move to test 2. We have been provided with a solution of nitric 5, a solution of aqueous ammonia, test tubes, a boiling tube, a solution of sodium sulfate. This is solid sodium sulfate from which the solution was obtained, and this is sodium sulfate. Sorry, this is lead 2 carbonate, which you are going to test, and this one is sodium sulfate from which this solution was obtained by adding water and sand. So we are going to start by carrying out test 1. We are going to follow the procedure for test 1. We are told add a trace of lead 2 carbonate to dilute nitric 5 acid. Okay, test for any gases produced. So we put our lead 2 carbonate inside here, and then we add dilute nitric 5 acid. This is our dilute nitric 5 acid. So we'll add until just a small amount remains. And we test for any gases produced by use of what? A splint. So we are adding nitric 5 acid, and we are supposed to test for any gas produced by use of a burning splint. So we light the burning splint here, and at the same time, we do what? We add dilute nitric 5 acid. So when we do that, this is a burning splint, we insert it inside. When you see it, it gets extinguished. Okay? So we add the acid, but we make sure which one is more? Which one is more?
The acid.
We make sure that the carbonate is more than the acid. So a lot of carbon 4 oxide gas is being produced. So we wait for the reaction to continue until at least we have a solution which we can use for the test. So you can check this like this. You can see a lot of bubbles are produced. You can still test to confirm what is being produced. It gets extinguished. So that is good. So we have, this is our acid. I hope you are seeing that it is dissolving and the solution that is being formed is colorless. But there are bubbles of gas which are produced. A lot of it is being produced. So you can shake it as we leave it to do what? We leave it for the reaction to reach conclusion. So what observation have we made? It is true. Solid dissolves to form a colorless solution. So here you write solid dissolves. Okay, solid dissolves to form a colorless solution. Solid dissolves to form a colorless solution. That is one. What about the gas which was produced? Colorless gas was produced. The color of the gas. We mentioned first of all the color of the gas. So you can see we are getting a clear solution, is it? So colorless gas produced. And that gas extinguishes a burning splint. Very good. So you say colorless gas produced extinguishes a burning splint. Okay, so this colorless gas that is produced and it extinguishes a burning splint is which gas?
Carbon.
It is carbon dioxide. So do we write carbon dioxide present or carbonate present?
Carbonate.
It is carbonate present. We look. We actually indicate the source of the carbon dioxide. Are we together?
Yes.
The carbon dioxide is from the carbonate. So right here. So that one. That inference here is for this one. Carbonate is present. When you write CO3 to negative like that, even without writing present, it means it is present. Are we together? So this one, solid dissolves to form a colorless solution. Then there's a possibility of what? It could have been zinc carbonate. It could dissolve to form what? A colorless solution. Are we together? It could have been what again? Lead to carbonate. It could still dissolve to form a colorless solution. Barium carbonate would still dissolve to form a colorless solution. So you can now write a list of any other carbonate which forms a colorless solution. Are we together? So what is absent? Because the solution is colorless, which ions are absent? Copper, iron, and what? Copper, iron, and iron 2 and iron 3. So you write capital letter C, small letter U, 2 positive, comma. Capital letter F, small letter E, 2 positive, comma. Your capital letter C should be bigger than small letter U. And these 2 positive must be a superscript, separated by a comma. Capital letter F should not be cutting. This side should not be cutting. Okay? 2 positive. And then capital letter F, 3 is positive. This one you now indicate absent. When absent, you must indicate it is absent. When positive, you can leave it the way it is. Are we together? I hope we have seen that. So the list, the reason why I have indicated the one which are absent is because the list of those which are present is endless. So here, we could be having potassium carbonate, so potassium ions could be present. We could be having sodium carbonate, so sodium ions could be present. We could be having zinc carbonate, so zinc ions could be present. We could be having lead 2 carbonate, so lead 2 ions could be present. We could be having barium carbonate, so barium ions will be present. In other words, the list of those which are present is long. Potassium carbonate, if you add dilute nitric 5 acid, it will still produce a colorless solution. And what? It will still produce a gas which extinguishes a burning split. Are we together? That's why we are just indicating those which are absent. So in the exam, I encourage you to write this, unless you remember also that this one could be present. But you just write what is absent, because copper 2 ions would produce a blue solution. Are we together? Iron 2 ions will produce
Green.
Iron 2 ions is which color?
Green.
You know, you should distinguish between when you have added sodium hydroxide and when it is just a solution. Like for example, iron 2 chloride, it is a pale green solution. Is it? Very good. Iron 3 ions in solution?
Brown.
That one is when you add sodium hydroxide. It is not brown, it is yellow. When you add water, it is yellow. But when you add the acid, it is yellow. But when you add now sodium hydroxide, then it will give you a brown precipitate. So do not mix the colors of adding water to the salt and doing what? Adding aqueous sodium hydroxide or aqueous ammonia to the metal ions. Be very keen on that, otherwise it can mess up with you. Are we together up to that point? Now let's go to the second test. We read the procedure there. We have decanted the 4 moment solutions, 2 different solutions. So we decant this, just a small quantity. We check it well because it is a clear solution to make sure that the ions are uniformly spread. So we just put a small quantity, and this one should be very clean. So we use one which is very clean, like this one. My friend, look for those which are very clean. So in qualitative analysis, we talk about 2 ml, but learn to use small quantities. Learn to use what? Small quantities. So we place this one here, then another one. This one is not very clean, so we leave this one aside because it will interfere with our observations. Look at this one again, not clean. This one, not very clean. This one. So we are going to carry out the first test using, this is test 2. To the first portion, add aqueous ammonia dropwise until in excess. So we go to where we have aqueous ammonia, which is this one. Now, a few drops is just about 3. Excess is even up to the top. So we just put here, few drops, 1, 2, 3. What do you see? There was a white precipitate, and the precipitate was dissolving immediately. So in a few drops, you are not supposed to mention whether it is dissolving or not. So what do you write? You just write white precipitate. Are we together? Yes. So here we write white precipitate. White PPT. Like that. Are we together? Now, we want to see whether the precipitate is dissolving or not. So we are going to add more of this. So you can even put the whole of this dropper like this. What do you see? White precipitate. Are we together? Okay. In excess, you can now add up to the top and see whether it is dissolving or not. What do you see?
White PPT.
Is it dissolving?
No.
Good. So look at that. Has it dissolved?
No.
This is a white precipitate, and the precipitate has not dissolved. So you just write white precipitate does not dissolve. White precipitate does not do what? Does not dissolve. Very good. So let's see. Does potassium form a white precipitate? No. Does sodium form a white precipitate? No. Does zinc form a white precipitate? Yes. Does the precipitate dissolve? No. The precipitate dissolves. For zinc, when you add excess of aqueous ammonia to zinc ions, it forms a white precipitate which dissolves. So the whole of this list up to here, all of them are absent because this one forms a white precipitate which dissolves. Okay? What about aluminium? Aluminium could have been present, isn't it? So there's a possibility of aluminium ions. What about barium?
No.
Barium hydroxide. Is it soluble or insoluble?
It is soluble.
Yes? Aluminium hydroxide, white precipitate does not dissolve.
Yes, sir.
But do we have aluminium carbonate? Anyway, let us not introduce what we were not given. We were looking for lead. See there? So what's the possibility? Is lead present or absent up to this level? Lead is present. So you write here, lead. Lead is possibly present. So the last test that we are going to perform here is to confirm the presence of lead. Are we together? So we add sodium sulfate. Why is the ones you have just brought? Okay, so we decant a small quantity again, like this. That's enough. And then, what do I add? Sodium sulfate, which is this. Yes, we add sodium sulfate, which is this. About how many drops?
3.
3 drops. So you place it inside here. 1 drop, 2 drops, 3 drops. Those are 3 drops. What do you see? White precipitate. Good. So you have the white precipitate. So what do you write here? White precipitate. What is the inference? Now we have confirmed the presence of B2 ions. So you write here Pb2 positive. And you are done. Now, we wrote the procedure, and then we have followed the procedure to confirm if it is actually present. Are we together? Yes. We could be having our procedure like this, but when you come here, you get different results. Like for example, solid dissolves to form a blue solution. Is it still lead carbonate amide? From there, it is already out. It is already out because a blue solution belongs to zinc. Sorry, to copper. A blue solution belongs to which ion? Copper. Very good. So this one must not be exactly like what we have got there. It could have been absent. Or maybe solid dissolves to form a colorless solution. Then colorless gas produced extinguishes a burning split. Then automatically we have a carbonate. Are we together? Then come here. Add aqueous ammonia dropwise until in excess. Then you form what? White precipitate dissolves in excess. Then what does that one tell you? It is zinc, not lead. Are you seeing that? It could be any other one. It's not a must that because you are testing for lead 2 carbonate, then you are given lead 2 carbonate. You can be given zinc carbonate, or you are given potassium carbonate. Therefore, you don't expect this has to be the same as we expected. So that's why we are talking about what? Expected observations when it is present. So if everything is the same way as we expected, then it means lead is present. But if it is not in the same way, then our lead is absent. Are you seeing that? So if lead ions are present, we have confirmed the presence of lead 2 ions. And we have confirmed the presence of the carbonate ion. Then which compound is present? Lead 2 carbonate. Which is the cation? Lead. Which is the anion? Carbonate.
Carbonate.
Are you seeing that? So which compound? Lead 2
carbonate.
carbonate. Let's stop there. We'll continue in our next class.